right now somewhere on Earth. The temperature breaks a new record every single day. The streets are empty. The asphalt softens and melts. Even the shade feels hot. An invisible lid has sealed the sky. The heat can't escape. This is a heat dome. We thought it would pass in a few days. But 1 week goes by, then 2. The lid doesn't budge. So someone finally asks, can't we just pop this lid? All right, today, humanity takes on the heat dome. To fight it, we first have to understand it. A heat dome isn't a balloon. There's no surface to pop. A heat dome is a giant lid of hot air trapped in the sky. So why does this lid form? There are 3 main reasons. First, the ocean overheats. When the sea gets abnormally warm, like during El Niño, the enormous heat it stored pours out into the air. Second, the wind-up high stops moving. Far above us runs a fast river of air, the jet stream flowing west to east. Normally, it keeps the weather moving along. But as the Arctic heats up, something breaks. The temperature gap between the pole and the equator keeps shrinking, and that gap was the very thing driving the jet stream. Weakened, the jet stream slows and wanders in giant waves, just like a river slowing down and meandering, and in one of those bends, a dome of hot, high-pressure air gets trapped. With no wind to push it along, the lid just sits there. That's why a heat dome parks over one spot and stays. Third, the ground dries out. When soil holds moisture, sunlight evaporates it, and that cools the surface. But once drought dries the land, that cooling disappears. Dry ground becomes a frying pan, heating up with no oil. The sun bakes it directly, and that heat cooks the air even more. A vicious cycle begins. Here's one crucial fact. Earth is a closed system where matter cannot escape. Heat generated inside cannot easily be thrown away outside. In fact, the only thing it could vent into space was heat. But greenhouse gases have slammed that last window shut. Keep this in mind, because every plan humanity is about to try will slam into this one wall. All right, first plan of attack. If a hot ocean feeds the heat dome, why not just cool the ocean down? Idea 1, drag an enormous Antarctic glacier all the way over and drop it into the hot sea. Cool the ocean with ice. But water is stubbornly hard to cool. The top 3 meters of the ocean hold as much heat as the entire atmosphere. To cool the overheated Pacific by just half a degree, you'd need enough ice to bury an entire peninsula several miles deep. No such glacier exists to move. And even if you could, there's a bigger problem. Hauling trillions of tons of ice over thousands of miles would take an unimaginable amount of power. And the heat from burning all that fuel is greater than the cooling the ice would provide. You'd warm the planet more just getting there. On top of that, Antarctica's white ice is a giant mirror. It bounces over 80% of sunlight back into space. So what happens if we peel it off and melt it into the sea? Where the mirror was, dark ocean takes its place, and dark water soaks up the sunlight instead. The planet gets even hotter, and that ice was sitting on land, not floating in the sea. Melt it into the ocean, and it's like dropping fresh ice cubes into a full glass. Sea levels surge by dozens of meters. Long before the heat dome cools, the coastal cities drown first. Fine, forget the glacier. What if we pump up cold water from the deep to cool the surface? Install millions of giant pumps across the sea. But that cold, deep water hides a secret. Cold water holds a lot of dissolved gas, like a chilled soda. And the deep sea is packed with carbon dioxide that sank down over centuries. Bring it up to the warm surface, and what happens? Like cracking open a soda that's gone warm, all that trapped carbon dioxide erupts out into the air. The surface might cool for a moment, but the greenhouse gas released only speeds up the warming, burning down the house to kill a single bug. And cold, heavy, deep water sinks right back down before it can even mix with the warm surface. To keep it up top, you'd have to stir the entire ocean forever. That deep water is also loaded with nutrients. Bring it up and plankton explode in numbers, then die and rot. The oxygen runs out, and the sea turns into a lifeless dead zone. Every attempt to cool the ocean hits the same wall. Cooling something doesn't erase heat. It only moves that heat from here to there. Inside a closed system like Earth, Whatever you cool in one place must heat up somewhere else. Then what about the dried out land? Just spray water on that frying pan ground to cool it, right? But water on scorching ground evaporates almost instantly. The humidity in the air skyrockets. And humid heat is far more dangerous than dry heat. Our bodies cool down by evaporating sweat. But when the air is already soaked with moisture, sweat can't evaporate. Shade, water, a fan, none of it lowers your body temperature anymore. The water meant to cool things down puts people in even greater danger. Here too, the heat never vanished. It only changed its form. If the ocean and the land both fail, what if we just push the stalled jet stream ourselves? Line up tens of thousands of massive jet engines, blast an artificial gale to shove the trapped hot air out, physically sweep the lid away. But picture the sheer scale of the jet stream. 6 miles up, hundreds of miles wide, a river of air wrapping the entire planet. The force this river of air carries is thousands of times greater than all the energy humanity uses in a year. A few tens of thousands of engines couldn't turn it by a single degree, and blast air upward toward the sky. And the reaction force drives the engines down into the ground. The sky won't move, only the earth beneath it breaks. And crucially, running all those engines means burning colossal amounts of fuel. The heat pumped out to make that wind only makes the dome boil hotter. The same wall yet again. The harder we push with brute force, the hotter the dome becomes. So let's flip the whole approach. What if we block the sunlight itself and the source of the heat before it ever reaches Earth? Scatter tiny reflective particles high in the stratosphere, or float a giant mirror in space to bounce the sunlight back. And here's the thing. This one kind of works. When a big volcano erupts, its ash blocks the sun, and the planet really does cool for a while. The problem is the side effects. Dim the sun too suddenly, and rainfall patterns, the monsoons, can collapse. The rains that billions rely on for food could simply vanish. And once you start, you can't stop. The moment you stop blocking the sun, all the held back heat comes rushing back at once. A violent rebound. An even hotter wave slams in. Above all, this doesn't remove the cause. It's just a lid laid over a boiling kettle. The heat is still building up right underneath. Why did every single attempt fail? The answer is in that fact we planted at the very start. Earth is a closed system. The energy inside a single heat dome defies imagination. It rivals every volcano on Earth, erupting all at once. Squeeze out the full might of human civilization, and it's still just a fingertip tap against it, and a massive pressure doesn't pop in the first place. Push one side away, and the surrounding air instantly fills the gap. There's no surface to burst like there is on a balloon. So no matter what we do, we hit the same wall. Heat never just disappears for free. The harder we force things to cool and run our machines, the more the total amount of heat grows inside a closed system. An unbreakable wall. It was the coldest law in the universe, thermodynamics. No machine we build, no force we can muster will ever beat this law. So is there truly no way at all? Actually, there is exactly one force that can lift a heat dome. The jet stream regaining its full strength. Then its wandering path snaps straight and it shoves the trapped lid away. But the jet stream isn't driven by machines, it's driven by temperature. And its power comes from the gap between the Arctic and the equator. So the only way to undo a heat dome is to cool the overheating Arctic back down. In other words, to stop heating up the planet. Here's the twist. The switch that turns off a heat dome was never some giant machine. It was the very ice we're melting right now. Heat domes have existed for ages, but they were never this deadly. Because the planet's baseline temperature itself has risen, the same lid descends, but starting hotter, it becomes a far hotter furnace. And even at this very moment, the planet keeps warming. If we don't stop it, in a few years, the heat will pass 104 degrees Fahrenheit, and no one knows how high it will climb. In the end, we cannot pop a heat dome, move the ice, stir the sea, block the sky. Each one only makes the planet hotter. But stop and think for a moment. It's strange. This colossal lid that none of our machines can build, we've already been building it little by little. The one and only switch to turn a heat dome off. It was in our hands all along. We just didn't want to press it.